Hello everyone, my name is Marie Karekla and I'm AIRA's Engagement and Program Coordinator. I'd like to welcome you all to today's iHub Summit 2 webinar series. Today's webinar on Living Labs is the last of the iHub webinar series taking place this week. Just before we get underway, if anyone has any questions throughout the webinar, please type them into the Q&A function that's located just at the bottom of your screen, and we will allow for some time at the end of the formal presentations to go through any questions you may have. So I'd now like to pass things over to AIRA's Chief Executive Officer and the Chair of the Innovation Hub for Affordable Heating and Cooling, Tony Gleeson. Thank you, Tony.
Thank you, Marie, and welcome to everyone to today's session. As Marie said, this is the second summit series and the third in this current series. And when we're welcoming people today, I'd also like to welcome and recognise through our Innovation Hub the traditional custodians on the land on which we meet today and which we all meet across Australia, and pay our respects particularly to the elders, both past, present and emerging, and recognise and celebrate the diversity of the Aboriginal peoples that exist on our lands. We recognise how country has been protected and cared for by the Aboriginal peoples over many tens of thousands of years, and their ongoing connection to land, water and community. So welcome to all. The other aspect I think it's very much important is also to recognise that the Innovation Hub is effectively an $18 million project with a $6 million grant from ARENA, the Australian Renewable Energies Agencies, and this is part of ARENA's Advancing Renewables program that we're talking about here today. As we move into today, we're looking at the Living Laboratories. Again, this is part of 3 streams that we run as part of this. The first being the Integrated Design Studios, the Data Clearinghouse, now the Living Laboratories. And today we'll hear from Queensland University of Technology in conjunction with University of Wollongong. And as you can see in all of these projects, there's a number of partners and participants which make this a significant impact upon what we're trying to do as we drive to a net zero environment. I particularly want to thank the Sustainable Research Buildings Research Centre in Wollongong, University of Wollongong, our project participants, Warragul, Bolton Clark, Queensland Children's Hospital, Sinenco, Stencil Australia, Environment Planning and Sustainability Department and the ACT Government. As you can see, we have got quite a number of players involved in these labs, and I'd like you to pass you over now to the leader of our Living Laboratories, and that's Wendy Miller. Wendy, over to you.
So the Living Laboratories program of the iHub is based very much on the, takes its lessons from the Green Proving Grounds program in the United States. The purpose is to validate the impact of integration of renewable energy, energy efficiency and heating, ventilation and air conditioning, as shown by some of these graphs on the right from the US. So looking at the impacts of efficiency, mixture of efficiency and generation or efficiency generation and load shedding or load shifting. That's the overall aim of the Living Laboratories as it is for the Green Proving Grounds in the United States. So in the iHub, we have 2 industry sectors that we're looking at for the Living Labs, that is healthcare and and schools, where we're wanting to quantify performance and nationwide or sector-wide benefits. And we have 4 Living Labs, so schools in the ACT, we have 2 aged care facilities, one in New South Wales and one in Queensland, and we have the Queensland Children's Hospital. As well as that, within these programs, we're looking at then what benchmarks or key performance indicators do we need to have in order to be able to quantify performance and validate the benefits and of new and emerging technologies or processes. So I'd like to now hand over to Daniel from Uni of Wollongong, who will tell you about the schools sector-wide activity and the Living Labs in the ACT schools and the Warragul Aged Care Centre.
Yeah, so very quickly I'm going to introduce the education sector-wide activities and then give a quick rundown on the two living laboratories, being ACT Schools and Warragul. So really the purpose of introducing the sector-wide in this context is really just to say that even though we're focusing on specific buildings in the education sector, an activity in this project is to then get as much data as we can about the broader education sector to try and understand where the buildings that we're looking at fit in. So the two graphs up here just show historically what information we know about schools' energy consumption. And what we can see really is that there's pretty poor data availability. So for some states, we don't really know anything. For other states, we know some things, but the most recent, I guess, comprehensive study was done in 2012, which found an average of 48 kilowatt hours per metre squared per year. For this current project, we're working with the state education departments to try and get access to more granular data. So this graph here shows energy intensity kilowatt hours per metre squared for the various schools in the ACT Education Directorate. So you can see there's quite a spread there, but up to sort of 225 kilowatt hours per metre squared down to 25 kilowatt hours per metre squared. And the schools that we're looking at are going to fit somewhere in that. And the goal of this project is to, I guess, keep expanding that graph to include New South Wales, Victoria, Queensland, various other education directorates. So moving on now to the specific living laboratories that I'm talking about today. So the living laboratory number one is essentially ACT Schools, but within ACT Schools, we have two specific schools that we're looking at, two case studies. So the first one on the left there is Amaroo, which is, I guess, a modern school, and the one on the left is Fadden, which is a bit of an older school. So Amaroo, constructed in 2004, fully operational since 2008. It's one of the largest schools in the ACT, gross floor area of over 16,000 metres squared. And going along with that, there's lots of students, goes from preschool up to year 10. So it's an example of a recently built school designed to include passive design, passive solutions to achieve thermal comfort. It's struggling to meet its thermal comfort requirements for various reasons, and I'll talk about that a little bit more. And it also has, as you can see, an enormous solar array, 600 kilowatts, and a small wind turbine as well. So our living lab, we took the bigger school, and given the size of it, we needed to break it into some functional areas. So we've come up with two functional areas within Amaroo. There's building 8 and the building 13 and 14 transportables. So just briefly introducing what is in those areas. So in the preschool area, which is the number one on the left-hand side of that image, that's two transportable buildings and an office space. So the heating there is provided by a gas furnace ducted to the classrooms. The office space has electric heating. And the transportables have split system air conditionings, all designed originally for passive cooling. So the office building designed for passive cooling, has ceiling fans and operable windows. Transportable classrooms have openable windows and AC. And as I say, cooling provided by the air conditioner. So the main building has a gas boiler with in-slab heating. It's got a BMS system that works to some extent. Again, designed for passive cooling, so actuated windows operated by the BMS. Large, so northerly aspect deep eaves, large windows, lots of thermal mass in the building. From the cooling side of things, there's been some issues with the actuators on the windows. So ceiling fans were introduced, and more recently, progressively standalone split system air conditionings have been introduced as well. So yes, that's sort of what that building is. Looking across the whole school, you can see there's very high gas consumption during the winter months. So there's large peaks of gas consumption during winter. The electricity consumption is relatively stable throughout the year, but this was from up until 2017, which was before most of the air conditioning units had been rolled out. So that may have changed in recent times. So what we've done in the past little while is installed a very comprehensive monitoring system in all the schools. So this is common across this system that we've used here is common between Amaroo and Fadden, the next door I'll talk about. So we've installed a weather station at each school, which this is all remote communication. We've installed energy consumption monitoring using Wattwatchers devices, and we've installed an IoT LoRa temperature monitoring system. Also includes CO2, occupancy, lux levels, that sort of thing. And we're monitoring gas as well, gas consumption as well. And we also connect into the BMS system, although that has sort of limited usefulness given that it's not the most reliable system. So here again, this is just our monitoring layout. I won't spend too long going into this. All this detail is available on the IHUB website in the Living Lab Operations Manual. So essentially, we've broken the school into these two functional areas that we're doing detailed monitoring on. Going down to give you an idea, we've worked through each classroom, trying to understand. So firstly, energy consumption, where the energy is being used, but then getting a pretty granular understanding of the temperature and humidity and internal environment quality in the different classrooms, so we can assess any change in that based on technology upgrades. Likewise for the transportables. So transportables give us an opportunity to do side-by-side comparison of technologies potentially. So we've instrumented the transportables quite in a very detailed way, including read switch on windows, things like that. So just to give you an idea, this is some of the temperature data, sample temperature data from spring 2020 that we're getting back. You can see this is a box plot showing mean temperature basically. You can see some of the areas. So all these particularly cold areas are the transportables. So we need to spend a bit more time to investigate whether that's to do with occupancy and usage of those transportables, or whether they are just in fact incredibly cold. All this information is just for school hours and excluding weekends and holidays. So you can see even sort of ignoring this hump down the bottom, there's quite a lot of hours below 18 degrees. So overall, 60% of hours are below 18 degrees in Amaroo. But as I say, we need to investigate the transportables a bit further. So opportunities that we're looking at for technology upgrades in this school. So electric heat pump to replace the central gas boiler. So moving to electrification of all heating. A BMS upgrade to provide automation. So as I say, the BMS, there is an existing BMS, but it's not particularly reliable and there's been some issues. Central thermal storage, and then demand side management solutions. So and demand response, I guess. So one of the unique things about this school is just the sheer size of the PV system that's there. So moving on to Fadden, and this will be much quicker. So Fadden, as I say, is a much older school. It's a much smaller school and obviously has much fewer students, and it's got a much smaller solar array as well. The school's classrooms are arranged essentially in 4 identical learning pods, and then there's a big administration section as well. The main thing to note for Fadden is that there's an ageing central gas boiler which provides heating for all the classrooms. That boiler is well past its useful life and needs to be replaced. So that's been the replacement has been put on hold at the moment until we got all the monitoring systems in place, so we could get some pre-consumption data. So the gas boiler replacement's an obvious opportunity. Similar to Amaroo, it was designed without any cooling, but evaporative coolers and split system reverse cycle air conditioning units have been progressively rolled out across the school. You see a similar profile with large gas peaks in the winter, but a much smaller peak compared to Amaroo on a kilowatt hours per metre squared basis. And as I say, limited mechanical cooling similar to Amaroo as well. So again, we've broken the school down into these functional areas. Essentially, we're looking at the administration building as one area, and that includes one learning pod. And this is basically driven by HVAC zoning. And then we have these two adjacent learning pods. So similar to the transportables at Amaroo, we've got two adjacent functional units that are good for side-by-side comparison. So I'm just showing one of those here, and you can see again quite detailed instrumentation in those learning pods. Consumption data. So you're seeing not the extreme cold conditions we saw in the transportables, but still 60% of the hours, and this is school hours excluding weekends and holidays and after hours, 60% below 18 degrees. So certainly cooling is an issue. Opportunities in Fadden, as I say, replacing the central boiler, implementing some BMS, and then central thermal storage and demand side solutions as well. So moving on now, trying to keep more or less to my time limit, I'll have to fly through Warragul reasonably quickly. So moving to the healthcare sector now, we also are managing one of the healthcare living laboratories, being the Warragul Shell Cove facility. So Warragul Shell Cove is a relatively new facility, opened in 2017, 9,000 square metres. It's got a main building with 3 levels, and then some community facilities around. So achieved 6-star NatHERS rating, high thermal performance glazing, building fabric, and yes, so relatively modern energy efficient building. It's got a 100 kilowatt hour solar array. Although as part of this project, we've identified that the solar array has been down for substantial periods over the last 3 years. So that's already one benefit, is that they turn their inverters back on. So one win for iHub. The HVAC system is variable refrigerant flow heat pumps, air-cooled condensers. So as I say, pretty modern energy efficient system. Controlling, so there's individual room controllers for temperature and fan speed, and a high level central system controller. So reasonably, comprehensive building BMS system. One thing of interest, and I couldn't help but put this image in, is just this is at the same time of day, same day, just seeing the diversity of what people have got their air conditioners set at. So these are adjacent rooms in the same building. So yeah, always interesting to see what people's thermal comfort is. We don't have historic energy data available for Warragul as yet. We're still chasing access to that. What we can see from our sample data, which is only spring in 2020, we can see sort of your typical duct curve due to the large solar array cutting out the consumption during the middle of the day, and the facility consumption is dominated by HVAC. Monitoring system is more or less the same as we have for Fadden and Amaroo. The main difference, I guess, is we have a bit more reliance, or we're using the BMS system a little bit more, just given that it's modern and a little bit more reliable, but still using the same Internet of Things temperature and energy consumption monitoring. So I don't expect you to be able to read too much into this graph. Essentially, the Living Lab is focused on level 2 of the main building, and then we've broken that into 4 areas based on directions, and we've chosen one of those HVAC zones to be a more detailed Living Lab. So the northeast section, we've installed some additional sensing and making sure that we know exactly what's going on there. So yeah, that's probably enough on that. Similar to the schools, just dividing up into sensible areas based on zoning. The temperature consumption, again, this is just for spring 2020. But what we can see is that it's a very comfortable building. So there's essentially no time where temperatures below 18 degrees were recorded or temperatures above 26 degrees. So obviously this is a shoulder season, but the HVAC system's doing a good job of maintaining thermal comfort in this site. So the opportunities for Warragul, there is still an opportunity for BMS upgrade to improve automation. central thermal storage is an option. And then again, given the very large 100 kilowatt solar array on this building, there's opportunity for demand response and demand side management. And that's a lot for me. So I'll pass back to Wendy to introduce the next.
Great, thanks a lot, Daniel. On from that, I'd like to introduce Dr. Sharif Zedan, who will talk to us about the Fernhill Aged Care Centre, which is in Caboolture in Queensland. Thanks, Sharif.
So the building in Caboolture is a new building. It's a new aged care building that is built on an existing aged care village. So let's watch a video to tell us a better idea about the building. So the building was completed in late August and got occupied in late October. You can see each of the rooms have ceiling fans as well as louvers openings for the windows and big sliding doors. And the reason is that Bolton Clark basically wanted the users or the occupants to have control of the air ventilation so that they rely less on air conditioning. And the other reason is that they wanted the residents to feel more or less in control so that basically they feel like they are at home more or less. But that in essence is a challenge always in buildings that combines between residential and commercial use, because the building also has workers who work there full time. So the design of the HVAC was challenging in that sense, because it had to combine between natural ventilation and also air conditioning in the common areas. Let me just skip to the end. Yeah, I just want to show you the, so that's the roof, and you can see the HVAC system as well as the PV panels on the roof. So the HVAC system comprises 3 chillers with variable speed water pumps and stored water tanks. The chillers can work separately or they can work collectively depending on the seasonality and the heating and cooling demand for the building. The building also has a BMS, which control and monitor the HVAC and lighting. The building is also equipped with weather station that can tell the temperature, relative humidity, and wind speed on site. The PV system is 100 kilowatt. It has 250 modules, and the estimated annual production is around 144 megawatt hour per year. The building is also hybrid in terms of lighting because it combines different lighting, like resorts to different types of sensors. So there's motion sensors, there are time clocks, and there are PE cells that responds to lux. So in the building, we have 6 rooms that are allocated for our living labs specifically. So the 6 rooms are located on level 3 so that the typical rooms above and below can also be included in a comparison when we are testing certain technology. The rooms are located on 3 different orientation as well to encompass the effect of the sun throughout the day. And we have installed a range of sensors. So sensors tell us the temperature, relative humidity, VOC, CO2, movement, and lux. And we are still putting more sensors depending on what we want to test. Now, because the building is new, so we don't have historical data for the new building. However, we have data for the energy use and temperature for the existing site, so the aged care village that the building is located in. And this analysis here show the comparison between the temperature and energy use in 2019 and 2020. And you can see that the energy use actually follows the patterns of the temperature. and it's predominantly cooling energy use rather than heating. We've done also correlation analysis between the temperature and energy use for the years from 2015 to 2020. And you can see that the correlation coefficient is more or less around 0.8. So that also confirms that the majority of energy consumption is because of the heating and cooling demand. We've done some initial testing, baseline testing on some of the rooms, basically to identify the impact of the performance of the building envelope. So we've done the tests on some rooms before they were occupied so that we can turn off the air conditioner the whole day and see the impact of the building envelope on its own, on the internal temperature. So we tested 3 rooms on the top level, so we can also get the chance to evaluate the impact of the roof on the room, so that the heat gains through the roof as well. So room 406 is facing north, where 405 and 408 are facing both north and east and west. So the 405 is on east, 408 is on west. And the blue line here highlights the glazing in each of the rooms. So you can see the glazing area and also the facade area to floor area ratio for 405 and 408 is quite high compared to 406. So this to show a comparison between the temperature in the 3 rooms and also the temperature on the external balcony. So you can see that room 406, which is facing north, is stable across the whole day. Whereas room 408, for example, which is located towards west, gain more heat during sunset. So there's quite a rise of temperature here. Whereas the room facing east, which is 405, gain more heat during sunrise. Now, because that test was conducted in September, so it was still cold back then. So you can see the effect of, so the temperature can get quite low during nighttime, but you can see that the performance of the envelope was quite good. It kept more or less the 3 rooms stable during that time. But that also indicates that the majority of the heat gain was through the windows, so through the glazing. So it might be a good idea to test the impact if we were to add some shade to the glazing areas. We've done air tightness tests. So we've engaged CTEC, who are an accredited ATMA professionals to do the test. So we've used 6 fans in 3 different locations. And after sealing everything in the building, and then we found that the air changes was around 10, which is typical for a commercial building. And we've done the test on the top level as well, which is the level that is more exposed to external infiltration. So we've run a smoke gun test to identify the leakage areas, the locations of the leakage areas. And what we found is that the majority of leakages were through the joint between the glass and frames. So for the louvers, it was in top and bottom. So I'll show you that video here. So you can see that smoke escapes just through the bottom and top, but actually the louvers, so the joints between the louvers themselves were quite well sealed, so we didn't get any leakage through that. The other location was between the 2 doors of the sliding doors. So that's the joint between the sliding door. Other areas of leakages were the perforated ceiling. So we're not sure whether that because of the ceiling space itself or because there are actually some leakages on the roof. So in essence, it might be a good idea as well to test some sealing solutions to make the building more airtight, perhaps just finding a way to better seal the window frames and then run the test again. We've also done VOC tests, and it showed that the majority of the VOC were inside the cupboard. So that's probably because of the paint and because the cupboards are not well ventilated compared to the other regions of the building. We've done 75 analytes to be tested in a lab, and we found that none of them showed any results above the limit of detection of the significant VOCs content. We are now in the process of testing the first technology, which is the honeycomb blind. So that should be installed, I think, next week. In essence, the honeycomb blind is a blind that is shaped like a honeycomb, which help trapping air and reduces the U values, increases the resistance against heat gain. We will be testing 6 different types of motorized blinds. So each room of the Living Lab room will have a different type, and the types vary in terms of the number and size of cells, so that we can compare the actual effect of each of the types, as well as comparing to the upper and lower rooms, which does not have the normal blinds. The test will include 2 parts or 2 streams. The first one is the short term, which will basically be testing baseline data. So we'll be testing the U values of the windows when the blinds are installed and when they are not, or when they are open. The long term would basically be testing and monitoring the effect of the blind when the building is being used as it normally will. So we'll be monitoring the occupational patterns of the operational patterns of the occupants. We'll be monitoring how they open and close the blinds. So we will install a range of string pots and reed switches to show when the blind and the windows are open or closed, and by how much the blinds are open or closed as well. So all of the data that we will get from the long term, we will input in an energy model, so that we can simulate the effect of the blinds if they were to be applied to all the rooms in the building. Well, we are still looking to install new technologies as well. And so if you feel like that there's anything that might be useful or would fit into the Living Lab, please contact me and we can go through the process. So we're looking for things that can reduce building heat loads, things about for the HVAC optimization or automation of programming of loads, as well as the precinct renewable. So there's a possibility for on-site storage and trading as well. So yeah, if you feel anything can actually be relevant to our Living Lab, please contact me. And I think that's it for me. So I'm handing back to Wendy.
Yeah, thanks, Sharif. If you can perhaps stop sharing. I'd like to now invite Dr. Aaron Liu, who will talk about Queensland Children's Hospital and what work's been done now and what work we expect to do in the future. Thanks, Aaron.
Thank you, Wendy. Hello, everyone. Good afternoon. This is Aaron Liu from QUT Brisbane. I'm the project manager for our iHub era Queensland Children's Hospital Living Lab. Here is a picture of our Queensland Children's Hospital, the main hospital building. It's a beautifully designed building. So let's start. We have here is a 3-year monthly energy use bar charts. We can see that generally we have a summer peak then electricity use and a bit low electricity use in the winter season. And please don't be distracted by the February low energy use. That's because February we normally have about 28 days or 29 days. But January and March have 31 days. You will see soon in the next chart. We have done further energy analysis and modeling. Here's a scatter plot of mean daily energy use in a month. That's a megawatt hour per day on the vertical axis. And the horizontal axis is the mean daily minimum temperature in a month. So it's the average of all days minimum temperature for a month on the horizontal axis. We plot the 3-year data along with the temperature comes from Brisbane-Bourne Airport data. We can see it's quite a linear relationship between temperature and energy use per day. If we do a bit of further data analysis, curve fitting, or sometimes we call it regression as well. If we use a very simple first order model, with the same data, we can achieve a simple one sentence version result. That is, 1 degree Celsius temperature increase may lead to 1.4 megawatt hour a day energy use increase for the QCH precinct. So that's the scale we're working on. And later we'll talk about the potential technologies that we are going to test and improve our energy efficiency, or further improve, because some of the buildings over there has already quite good energy efficiency. Okay, this chart is a QCH precinct monthly peak demand. So it's also by month, that's January to February on the horizontal axis, and the vertical axis, that's kilowatts. So we normally see that the summertime of February particularly, we tend to have very high peak demand. And also in the winter, we have low peak demand. That's often related to the HVAC heating, ventilation, air conditioning use. This is a general pattern for almost possibly all commercial buildings. And if we plot the monthly peak demand data and scatter plot again with the same mean daily minimum temperature in a month, we can see also similar pattern, but a bit scattered relationship. It's also 3 years data, 2017 to 2019 data with the Brisbane Airport temperature data. And if we do similarly, the curve fitting or regression study, we can find out that actually that's a 1 degree C temperature increase may lead to 85 kilowatts electrical demand increase for QCH precinct. Here we are going to talk about the potential technologies. And this is a picture of the energy plant for QCH precinct. Energy efficiency or renewable enabling technologies can be tested on the energy plant. For example, optimizing the operation of HVAC in terms of reliability, cost performance, and predictive maintenance, or some other technologies to improve HVAC chiller efficiency and water treatment, and heating electrification as well. Here is a picture of the Queensland Children's Hospital main hospital outdoor plant room. It has a few condensers for cooling rooms and for freezer. What we're going to do is we're going to test graphene-aided paint. It's called the thermal XR system onto condensers in the outdoor plant. And the GMG is our Brisbane-based Australian company. The thermal XR coating system is graphene-based. Why it's good or how it works is because graphene offers high strength and improves thermal conductivity and has a property of corrosion protection. Here is a chart from an IGA shop in Brisbane. That's the red bar indicates that at the time that they implemented the thermal XR, we can see an improvement in terms of energy use before implementation and after implementation. This is a result from the testing results, and we are going to do tests independently to verify the performance improvement after the thermal XR system. And we are inviting more technologies to be tested in our iHub Living Lab. And here we have slightly different focus compared to other Fern Hill Living Labs. Here, for example, we can more focus on reducing building heat loads, HVAC efficiency improvements, optimization, predictive control, precinct, or off-site renewables. So if you are interested, please contact me. That's my email address. And we have more information about the Living Labs or our previous documents or reports on ihub.org.au. Thank you. Wendy, please.
Great, thanks very much, Aaron. So I hope you found that interesting. I'm just going to bring up a share screen again now. That actually bring it down. That one of the key things that the Living Labs are looking at is also what key performance indicators do we use to tell whether something is energy efficient or resilient, a range of things. So we've been looking at a range of energy use intensity metrics, so EUIs, and typically in hospitals, as in schools and aged care centres and a lot of office buildings, that the main key performance indicator used is kilowatt hours per square metre. In hospitals in different international literature, there's a range of other key performance indicators that have been suggested, such as energy use per full-time equivalent staff, so looking at the size of the hospital in a sense of its busyness, or per staffed bed per square metre, or per floor area per cooling degree day, or even looking at what types of equipment hospitals might have. So there's a energy use intensity per MRI per square metre. So the hospital KPIs, though, still don't really tell us a lot of things, because the hospital use depends on, the climate and cultural expectations, the age or energy efficiency of the building and infrastructure and equipment, and the degree of medical specialisation, building size, etc., as well as national and regional healthcare budgets. I'm going to see if I can change to the next slide. And similar with aged care centres, that typical energy use intensity things are kilowatt hours per square metre or per resident, or heating or cooling per square metre or per resident. But the use, one of the things with aged care centres is that, as well as with hospitals, that we need to understand better the end use category. So what are the internal energy services, the load types, tasks and appliances? Who are the end users? Is it residents or staff or visitors? And are the loads within those buildings deferrable or interruptible or variable? And what type of building use or characteristics? And each of these types of samples can have different key performance indicators, and each type of performance indicator can have a different use. So we have to get much more sophisticated in what KPIs we use, and not just look at kilowatt hours per resident or per school student or per square metre. So some of the other things that we've looked at in terms of data analysis in the last number of months, for example, with aged care centres, so with Bolton Clark, we actually looked at the energy use data of 6 aged care facilities, so 2 in southeast Queensland, 1 in Townsville, 1 in Cairns, 1 in Toowoomba and 1 in Sydney, and looking at the period from about mid-March to the end of April, when all aged care facilities were under national lockdown because of the first wave of COVID-19. So under that period of about 40 days, we looked at the energy use of those 6 facilities, looking at kilowatt hours per bed, kilowatt hours per bed per cooling degree day, the timing of peak demand, the renewable energy potential, the temperature and energy correlation, etc. Here's an example of some of that analysis on the right, which I won't go into now. But in essence, what these types of KPIs, so kilowatt hours per bed or even per bed per cooling degree day, they don't give you any visibility of the internal breakdown of what's happening, although you can give a guess in some places that it's air conditioning related because of the correlation with energy, but you don't really know the uses and the users of that breakdown. And also specifically with the COVID-19, there's no consideration of the ventilation requirements for infection control in any of that data, because you can't separate out ventilation or indoor environment quality issues in classrooms, for example. The other piece of work relates to the International Energy Agency Annex 80, which is resilient cooling in buildings. And we've been looking at, so one of the key tasks of this agency is to look at what key performance indicators do we need for being able to verify what is a resilient cooling system. And the key question was resilience of what and from what. And an interesting equation from other literature could see that resilience of cooling of buildings is a function of both the system and of the threat or the perturbation, the threat, where the system is a combination of society's processes and the building occupants, buildings, cooling technologies and energy systems. So how exposed are they? How vulnerable, how resistant, how robust, how quickly can they recover, and all of those things. And then we also need to understand and have KPIs that measure what the threat is. So if it's so the probability of occurrence, what type of threat, the magnitude, intensity, speed, persistence, etc. So with the changing climate, it's not just heat waves or the magnitude of a heat wave that's important. It's how long does a heat wave go for, but it can also be things like how many heat waves in a row, the intensity, duration, whether a heat wave happens at the end of August, end of winter, early spring, like we had, I think, the year before last in southeast Queensland, or whether it happens during a holiday period where a lot of people are out of their offices, etc. So we're looking at, from the International Energy Agency, what types of key performance indicators we need to be able to provide more granularity on that energy use. So with all of those presentations then, are there any questions that people have regarding any of the specific living labs? I'm going to stop sharing my screen and invite all the speakers to, put up your, turn on your microphones, turn on your videos so that people can ask a question. So we have a question here from, addressed to Daniel. Thanks for your professional informative presentation. Can you tell us which U value the windows have in the buildings that you mentioned?
I hope you can hear me. Short answer to that is to the fact value, no, I can't. So all the details will be in our, well, as much detail as we have will be in our, on the iHub website, which is org.au. So for each site, we've produced a detailed operations manual, which lays out in much more detail what the building fabric is and what the monitoring systems that we've installed are. So that's probably the best place to go to look. Off the top of my head, it's there's nothing special in Fadden certainly, or and I don't think in Amaru either. And then Warragul has some advanced glazing, but I'd have to go back to the operations manual to find out the exact details. So I'm happy to, I think there was an email included on that. Oh, there's a phone number included. So I'm happy to chase up those details and pass them on.
That's a good thing to remind everybody that each of the 4 living labs has produced a fairly detailed operations manual that describes the buildings and the systems, and also the process that any living lab testing will happen, and all of those documents are on the iHub website. Are there any further questions? So I think with all of the living labs that there's potential for improving the building envelopes as well as the operation or efficiency of HVAC systems, and then the integration of systems, which are things that aren't typically done, particularly in schools and in aged care centres compared to 6-star office buildings, for example. Are there any further questions? I want to thank you all for your participation today, and please feel free to contact Sharif if you have some ideas regarding the Fernhill Aged Care Centre at Caboolture. Aaron, if you have questions about the Queensland Children's Hospital. Daniel, about any of the University of Wollongong, so the ACT schools or the Warragul. And myself or Georgios from Uni of Wollongong about any of the sector-wide activities in particular. And our contact details are on the front slide of this presentation. So thank you all for participating today, and please feel free to contact any of us with any questions that you have in the future. Thank you and goodbye.
Thank you, everyone. And just to echo on Wendy's words there, so thanks everyone for registering and attending today's webinar. And a thank you to our activity leaders, project partners, and of course today's presenters. If you do wish to watch any of the iHub webinars from this week, the recordings will be made available up on the ERA website about the coming next week or so, and I'll send out an email and let everybody know when that does become available. For more information regarding the Innovation Hub, please visit the website that's up on your screen, which is ihub.org.au. So thank you all again for coming along to the second series of the iHub webinars, and we look forward to you joining us once again in 2021. So until then, take care, and I hope everyone enjoys the rest of your day. See you later.